On the top of page 2, we're going to be talking about the domain of functions. And to me, the domain of a function is just where the function exists. So if you have not yet read that text, maybe pause the video, read that real fast. But let's talk about some functions that we know that are defined for all real numbers. So all of your polynomial functions are defined for real numbers. So when you were working, for example, in Algebra 2 with like end behavior, well, the reason we can talk about end behavior is that those functions go on forever in the direction of negative and positive infinity. So there's never a place where a parabola, for example, does not exist. For our exponential functions, and I'm going to reference some stuff over here. So these are the graphs from page 119. So if I look at this exponential with a base e, the exponential functions, their domain is unrestricted. Now the range is restricted, but that's not what we're talking about. So the function y equals e to the x, it exists for every real value of x. So again, we can express that domain as either using this interval notation from negative to positive infinity, or if you write the real number symbol, I just do two straight lines and then the rest of the r. I don't always write it exactly as it's printed. All right, our sinusoidal functions, sine and cosine. Coming back over here, here are our two sinusoidals. And they exist everywhere. For every real value of x, you could plug them in and obtain a value of y. All right, radical functions with odd indices. So meaning a cube root, a fifth root, a ninth root. If the index is odd, we can let's see, sorry, we can evaluate it. So even if, let's see, I can take the cube root of -8, for example. So the cube root of -8 is just -2, and that's a real number. So that has, it has an unrestricted domain as well. Rational functions where the denominator is never 0, cannot be 0. So in this one, for example, 1 over 1 plus x squared, 1 plus x squared can never be 0. And then lastly, our inverse tangent and cotangent functions. So remember that there's two ways to write the inverse. The arc tan of x is the same as writing it this way. But those are going to have unrestricted domains as well. And what I would say for the inverse functions is to just think of it this way. The inverse tangent and cotangent functions will have the same domain restrictions as the range of the tangent and cotangent functions. So again, all of these graphs are on page 119 of your spiral if you need to look at them. So if I look at the tangent and cotangent functions, if I look at the range, and it's not marked on here, but these go on forever. So you could put little arrows on here if you wanted to. The range of these functions is all real numbers. So their inverse functions will have a domain of all real numbers. All right, so this top section, these are all unrestricted.